Okay, so today we are doing covalent bonds, and these are the three things that we are covering. And yeah, before we carry on, please do make sure you download your own copy of the PDF. The link is in the description so you can be making your own revision notes as we go through today's video. So let's get started. So yeah, what is a covalent bond? So covalent bonding is chemical bonding formed by the sharing of one or more pair of electrons between two atoms. So yeah, the key thing really is it is a pair of electrons, and yeah, it is between two atoms. So that's really important. So let's have a look at what is going on. So here is what AI thinks a covalent bond looks like, and it's kind of right. So we've kind of got one atom, we've got two atoms, and then yeah, they bond together to give you a molecule. And here is what you need to know. So this is your hydrogen. So this is the simplest of the covalent molecules. So we've got our positive protons, and then we've got our pair of electrons. And how is the bond? Where is the bond coming from? So so it's the electrostatic attraction between the positive nucleus and the pair of negative electrons that form the bond. So this is where the attraction comes from, and our covalent bond is very strong. So there we go. Okay, so let's look at some examples through the form of dot cross diagrams. So we are not going to go through all of them. There is all the examples you need to know, like the outlines for them. We're just going to go through a few now. So so with these diagrams, again, we only care about the outer shell electrons. And how do we know the outer shell electrons? Well, it's from the group number. And then from that, we can figure out how many electrons that atom needs. So so we know that a covalent bond is the sharing of a pair of electrons. And that is basically what's going on. So unlike ionic bonding, where electrons are donated, this is sharing, so then both atoms feel like it has the 8 electrons that it is after. So chlorine is in group 7, so we know chlorine has 7 electrons in its outer shell. It needs 8, so because it needs 8, it needs 1 more electron. So it has to share 1 electron. So the number of electrons that it needs is the number of electrons that it shares. So let's fill out our diagram. So again, it's dots and crosses. So one chlorine is going to have dots, the other is going to have crosses. So chlorine needs to share 1 electron. So let's put that in the shared space. So that middle part there is the shared zone. And then we put in the other 6. There we go. And then we've got our other chlorine. It needs to share 1. And then we'll put in the other 6. Okay, there we go. And just to complete our diagram, we can put our chlorine in the middle there. So how do we know our diagram is correct? Well, if you go around the circle and you count to 8, you have done it properly. So if we go around here, we have 8 electrons. And if we go around here, we have 8 electrons. Happy days. And then just a few key things to look at. So with the shared electrons, so the shared electrons has to be in the shared zone. It can't be on the line, it has to be in the shared zone. And the non-bonding electrons, they have to be on the line. Okay, so these are 2 really important things with these diagrams. All right, so let's do a few more examples, and then you can have a go at doing the rest all by yourself. So let's have a go with water. So water so water has 2 hydrogens and 1 oxygen. So oxygen is in group 6. So oxygen has 6 electrons. It needs 2 more electrons. So oxygen always shares 2 electrons. And hydrogen has 1 electron. It always needs 1 electron to have its full outer shell. So it only needs 2 to have a full outer shell. So hydrogen always shares its electrons. So first of all, where are the elements going to go? So oxygen is going to be bonding twice, and your hydrogen can only ever bond once. So there we go. And let's put in our hydrogen, so hydrogen's the easiest, so we can do hydrogen first. So hydrogen is always sharing its 1 electron, and then oxygen is sharing 2 electrons, and there's 2 shared zones. So let's put one here, and then yeah, we've got the other electrons going there. So let's check our diagram. So if we go around here, we've got 8, and yeah, hydrogen always has 2. So there we go. And again, we've got our electrons in the shared space there. Happy days. Okay, so yeah, so the other examples you need to go through, I'm not going to do these ones, like these are the simpler ones. So we've got methane, CH4, hydrogen chloride, HCl, yeah, NH3. And then yeah, these are some of the trickier ones, but this one here, so this is still single bonds, but we're going to look at some double bonding now. So a double bond is where you're sharing more than 2 electrons. So in C2H4 we have a double bond. So let's have a look at what is going on. So we have carbon. So carbon has 4 electrons. So therefore it needs 4 more. So carbon, just like hydrogen, is always sharing all of its electrons. But where are those electrons going to go? Well, first of all, let's figure out that this is carbon, and yeah, hydrogen is always on the outskirts because it can only ever bond once. So yeah, so carbon has 4 electrons and they all have to be shared. This time we've only got 3 shared spaces. So we're going to have to put 2 here, 1, 2, and then 3, 4. We can do the same again for the other carbon. So yeah, 1, 2, 3, and then 4. And then let's do hydrogen. So yeah, so 1, 2, 3, 4. There we go. So we can check our diagram is correct. So as we go around here for this carbon, we have 8 electrons. Go around here, we've got 8 electrons, and then yeah, hydrogen is very easy to check. So this is always what hydrogen looks like. Okay, so yeah, let's have a look at this shared zone. So this is what a double bond looks like. So yeah, you have to do it like this. It has to be like X0, 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 or dot cross, dot cross, dot cross. So you can't do, anything. So you can't like do this, or you can't do this, or you can't do this. It always has to be what we've got over here, okay? And the mark scheme, very annoyingly, is very pernickety about these things. So there we go. And then again, we've got some more double bond examples. Let's just have a look at a triple bond, and then you can do the rest. So we have nitrogen. So nitrogen is in group 5, which means it has 5 electrons in its outer shell. So therefore it needs 3 more. So each nitrogen is going to share 3 electrons. So we've got a nitrogen, we've got a nitrogen. So each nitrogen is going to share 3 electrons. So let's get those drawn in. 1, 2, 3. And then 4, 5. And then 1, 2, 3, 4, 5. And then again, we can see 8 electrons. 8 electrons. Our diagram is all good. And then we look in the shared area. So here we go. So again, just like with the double bond, it has to be in a line. So like X0, 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 dot cross, dot cross, dot cross. Happy days. Okay, so a few more examples for you to be getting on with, but let's get down to it. So the properties of the covalent molecule. So just like with the ionic bonding, how the bonding and the properties of the molecules are linked, it's the same with this. So with the covalent molecules, these are very simple, so they're much smaller. So they're called simple covalent molecules. They all exist as very small things. They don't have a giant structure. They're not never ending like with the ionic compounds. They have a definite structure that ends. So nitrogen is always N2. It's 2 nitrogens bonded together. So if you had a balloon filled with nitrogen, it would just be billions of this molecule. So because of this slight difference, this means we have a big difference in properties. So because they are very small molecules, as we can see here, they are, as a majority, they exist as gases. So gases have very low melting and boiling points. So the covalent molecules have very low melting and boiling points. And that's because the intermolecular forces, so the forces between the molecules, is very weak. So even though they have strong covalent bonds, the interaction between the molecules is very weak, and because of that, they are, as a majority, yeah, either a gas or a liquid at room temperature. So that's one thing you need to know. And then, yeah, the second thing is to do with electrical conductivity. So we can see that this light bulb is not turned on, and this is because, yeah, they are very poor electrical conductors. And that's because there's no charges, so none of these molecules are charged, and yeah, there's no way of carrying a charge through a circuit, so that's why they do not conduct electricity. Okay, so that is everything from me today. Next video we're going to be comparing the different structures, so that comes up a lot in exams, so we're going to be comparing the different structures. So yeah, stick around for that, and yeah, as always, thank you for watching, and please do tell all of your chemistry friends about the channel. All right, ciao, catch you in the next one, bye.